Welcome to Module 4 File System Implementation. So, in the previous lecture, we have covered some of the topics of this chapter. Those are file system structure, file system implementation, and directory implementation. So, now we'll move to the next topic that is called as a allocation methods. So, as we discussed here, to allocation method refers to how disk blocks are allocated for the files, and here we are going to cover the three different methods: contiguous allocation, linked allocation, and indexed allocation. So we'll go on discussing one by one here in this chapter. So contiguous allocation means contiguous allocation requires that all blocks of the file be kept together contiguously. So you kept all the blocks contiguously, and each file occupies a set of contiguous blocks on the disk, and the performance is very fast because reading the successive blocks of the same file generally requires no movement of the disk heads here, because the file or continuously, or the blocks allocated for the files is contiguous here. Once you start reading, it will go on reading till the end of the file. So problem can arise when the files are grow here. So if the exact size of the file is unknown at a creation time, then we are going to face the file. As we allocating the blocks for the files contiguously. So for example, there are two files, file 1 and file 2, and for the file 1 you allocated a 3 blocks, and followed by file 2 is going to get another 2 blocks. So contiguously we have allocated first 5 blocks, and if the first file starts growing and it becomes a full, so later we cannot able to allocate the extra blocks because the next blocks are allocated for the another file that is in the file. And another problem we are going to face with contiguous allocation, that is random access of the blocks randomly is not possible, and there is a wasteful of space. Dynamic storage allocation problem means we cannot allocate, or the blocks are scattered. If you go on inserting or updating the information, some blocks are going to become empty or free in between the file system, and those blocks we cannot be utilized because they have scattered over the file or a disk. So here files cannot grow because that we have seen. If you allocate the blocks to the files contiguously, we cannot grow the files. This is another problem that we are going to face with the contiguous allocation. And another problem that we have covered here, wastage of space, and this is called as a external fragmentation. You know that fragmentation means dividing the given memory into multiple parts, and there are two types of the problems: internal and external fragmentation, that we have covered in the memory management. Here there is a problem that is called as a wasteful of space, that is external fragmentation. So this is one example how you are allocated contiguously allocation of the disk space. For example, if you consider there is a directory we are going to maintain. So what are the files that we have maintained in the disk, and what is the length of the file, means blocks you allocated. So there is a one file called as a count, and it requires the length of the file is 2 blocks, and it is going to start storing from the 0th block. 0 and 1 are used for the count file, and there is another file called as a f. It also requires 2 blocks, and it is going to be stored contiguously 6 and 7. And next you consider a list, that is 28 and 28 starting address. It requires the 4 blocks. Which file here? List. It is shown here 28, 29, 30, 31. Next you consider a mail, another file. It requires 6 blocks, and it is going to start from 19, 20, 21, 22, 23, 24. There is another file called as a tr, and its starting address is 13 and requires the 3 blocks here. How many blocks you require here? 3 blocks, that is called as a 14, 15, and 16. So these are the different files we already going to maintain or allocated blocks from a disk. So now what is going to happen here? We are going to face the files problems here. So if you want to access the file directly called as a tr, it is not possible directly. That means random access is not possible. We have to start from 0 and so on here. So another problem that we have told, that is wastage of space. So if you now you want to store another file consider as a student, and it requires the 6 blocks. How many blocks it requires here? 6 blocks, And if you want to store the file contiguously, then there is a no 6 blocks contiguously available. Here it is available 1 2 3 4, and here it is available 1 2 3 4 5 6. Okay, it is available. We can store the file student from the starting block called as a 8, and then it will go on storing 9 10 11 12 13 here. Now consider there is another file arrives called as a employee you want to store here, and it is also going to have a 6 length of the file is 6 blocks. Now you verify here the 6 blocks are available here, 1 2 3 4. Another 2 blocks are available here, 17 18. Means the blocks are going to be scattered over disk, and those cannot be utilized here. This is called as what? External fragmentation. This is a problem we are going to face with the contiguous allocation. And another problem that we have faced called as a, if the file want to grow, that is not possible here. The block means, for example, here you can see the example. You stored here the file called as a count 1 2, and if you stored another file called as a employee with the 4 blocks, that is 2 3 4 5 here, and after that it is going to contain the file f67. Now if the file count start growing here, and it becomes a full with the both blocks, that is 0 and 1, and if you want to allocate another block to the file count, is not possible with this contiguous allocation of the disk space. To overcome these problems, we are going to use a method called as extent based system. So extent based system means here some of the free holes are going to be maintained, and that part we are going to call it as a extent. And many newer file systems use a modified contiguous allocation. This method we are going to call it as a modified contiguous allocation scheme. Here extent based file system allocate the disk blocks in extents. An extent is a contiguous block of disks. Extents are allocated for the file whenever they required, and a file consists of one or more extents here. File consists of one or more extents. This is how we are going to overcome the problem of the contiguous allocation. If the means whatever the problems we have discussed, wastage of space, and another problem, file cannot grow. These problems are going to be overcome by using this extent based methods. So you allocate extents are allocated for a file allocation. The next method we are going to discuss called as a linked allocation. So whatever the problems we are going to face with the contiguous allocation, that we are can going to overcome with the linked allocation. And this so first of all we'll see the free space management here. One simple approach is to use a bit factor in which each bit represents a disk block set to 1 if it is free, or 0 if it is allocated. Means if the block is allocated, we are going to assign 0. If the block is free, we are going to set to bit is 1. Fast algorithm exists for quickly finding contiguous blocks of given size. Now consider here one example here. Consider disk where the blocks 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 17, 18, 25, 26, and 27 are free, and the rest of the blocks are allocated. The free space bit map would be looks like below. That is 1 2 are used here, 0 1 are used, are set with a 0. 0 means allocated. Then 2 3 4 5 are free, set with a 1. 6 7 are used, set with a 0. And 8 9 10, 11, 12, 13 are free blocks, so on like that. We are going to set with the value bits 0 and 1 here. So this is how we are going to manage the free space management. So bit vector n blocks is a diagram shown here, 0 to n minus 1, and bit of I is equal to 0 means block is free. If bit of I is equal to 1 means it is occupied. Sorry, here bit of I is equal to 1 means block is free, and bit of 0 means occupied means allocated here. So now how to calculate the block numbers here? Block number calculation is equal to number of bits per word into number of zero word value words plus offset of first one bit. So this is the formula we are using for the calculation of the bit or free space management using the bit vector. So once you got it, free space management. So bitmap requires extra space, that is block size is equal to 200, 2 raised to 12 bytes. Then the disk size is 200, 2 raised to 30 bytes. Then n is equal to 2 raised to divided by 2 raised to 12, and the 2 raised to 18 bits or 32k bytes are going to be are required for the implementation of the bit vector here. Easy to get the contiguous files here. Easy to get the contiguous files by using the bit vector. And for managing the free space management, need to protect here. How to protect here? The blocks pointer to the free list and bitmap must be kept on the disk. Copy in the memory and disk may differ. Cannot allow for block I to have the situation where bit is equal to 1 in the memory and bit of I is equal to 0 on a disk here. The solution is set bit I is equal to 1 in a disk, allocate a block, and set bit I is equal to 1 in a memory. This is the method we are going to use for the protection and the problem that we have faced for the bit vector. So once you got it, the bit vector method or a technique for the implementation of free space management. Now we'll go to the another method called as a linked list. A linked list can also be used to keep the track of all the free blocks here. So traversing the list for finding a contiguous block of given size are not easy, but fortunately are not frequently needed operations. So generally the system just adds and removes the single blocks from the beginning of the list, and the file allocation table keeps a track of the free list as just one more linked list on the table here. So just we'll see the diagram here how actually the linked technique or method we are using for free space list or free space management. So consider here you start with the first, so go on searching the which blocks are free or which blocks are set with the 1. So if the bit is set to 1, it is free. 0 means occupied. So if it is 1, then it will start starting address of the linked list is 1. Here next block is also 3 is also free, 4 is also free, 5 is free, 6 7 is allocated, 8 9 10 11 12 13 are free, 17 18 are free, 25 26 27 are free here. Last it is, and this pre-linked free allocation free space management is used for the allocation of the blocks in the using linked allocation method. This is another method we are using for the space management, and some more methods we are using called as a grouping and counting. It is another variation on a linked list. Free list is to use a links of blocks of indices of free blocks here. If a block holds up to a n addresses, then the first block in the linked list contains up to n minus 1 addresses of free blocks and a pointer to the next block of a free addresses. So we are going to group all the free spaces in the one disk or one block here. So another method we are using called as a counting. When there are multiple contiguous blocks of a free space, then the system can keep track of the starting address of the group and the number of contiguous free blocks. So as long as the average length of the contiguous group of free blocks is greater than 2, this offers a saving in space needed for the free space list. These are the another two methods we are using for managing the free space. So this is about free space management, and these are the topics that we have covered under the file system implementation The topics are system structure, file system implementation, and allocation methods, directory implementation, and the last topic that is called as a free space management. This is the end of the chapter number 11 of module 4. Thank you.